Hey everyone, welcome to yet another exciting video. Today we are starting a new journey in attaining a skill set which is essential for any data analytics professional to succeed. I'm talking about SQL or Structured Query Language. Keeping in mind the recent enhancements and demand in cloud technologies, I will be explaining SQL concepts using a popular cloud platform from Google which is known as BigQuery. This will ensure that along with gaining the essential knowledge about SQL, you'll also get to work with GCP or Google Cloud Platform. Since Google offers a free tier for BigQuery, you don't have to worry about making any payment for using the basic services that we will be using in this series. Now the best thing about BigQuery is that literally there is no setup time involved. If you look at other traditional database systems, it involves a lot of installing softwares and setting up your database and all those things. Here, the setup time is literally none. All you have to do is you just need a Gmail ID and then just log into this link, which is console.cloud.google.com. The links will be in the description just in case you want to follow along. Now, once you have logged in, you will see a screen similar to this one. GCP will create a project for you by default, which you can see here. You can see a project number here, and then you can see a project ID here, right? And this one simply says my first project. Since we are focusing on only SQL, you don't have to worry about anything else here. You just have to click on this button which says run a query in BigQuery. Okay. And it will take you directly to the SQL workspace. This is the Explorer Planner, which stores your databases and data that you add to your workspace. This area contains the editor window. This gives you a welcome window first, and then if you close this out, you can see an editor window as well. Now the entire thing is running on a sandbox. Once you are done with the basic introduction into BigQuery and SQL, you can choose to update your profile to get the paid services which have much more features in it. But for now, you don't have to worry about that. Just use the free tier. As I said before, by default, it creates a project for you, but you can add multiple projects as well. In the free tier, you can create up to 10 projects. The way you create a project is just by clicking on this drop down here and click on new project. It will intimate you how many projects you have left in your quota, and then you can give it a name and you can give a location and all those things. But for now, we're going to use the same default project that it has created for us to work on SQL concepts. Now, we're going to see how we can import any dataset into your BigQuery environment so that you can start working on that dataset and start writing SQL queries. But before we load any kind of data into BigQuery, we need to understand the structure, how the data is loaded into the BigQuery. Whenever you try to upload any data into BigQuery, it gets stored inside a folder which is known as datasets. This is how BigQuery organizes your table of data into its ecosystem. So every data that you upload gets uploaded as a table inside a organized folder which is known as dataset. Now once you upload something, it gets uploaded to a specific region. So your dataset gets stored into a data center of a particular region of your choosing, or you can also let Google choose the region automatically. So as I said, before you load your data, you need to create a dataset, a folder which will host every table that you have. So to create a dataset, what you need to do is you need to go to your project name. So we're using the default project that BigQuery has created for us. But if you choose, you can create a new project by clicking on this project drop down here and creating a new project. For now, I'm going to just stick with the default project name and click on this 3 dots icon. And within this, click create dataset. Okay. It will ask you for a dataset ID. Now, the data that I'm using today is an open powerlifting dataset that I downloaded from Kaggle. Links will be in the description if you want to follow along. Now, this dataset contains 2 tables in it, and we're gonna load both of them. Now, there are certain quota limits that you would encounter when it comes to loading your data or storing your data onto Google servers. You can read about those quota limits in the link that I've pasted in the description below. Now, when it comes to creating the dataset, you need to give it a name. So I'm going to choose powerlifting. The second option says location type. You can choose to store your data in one region, or else you can also choose to store your data in multiple regions. Multiple region will have much more bandwidth as compared to one region. So I'm going to choose multiple region, and from the drop down, I'm going to choose US. Google will automatically choose which all region it wants to store the data within all the data centers that it has in United States. Default table expiration. I'm not going to check this out, but what this means is if you check this, it will automatically delete your dataset after a certain period of time. Okay, I'm not going to do that, and I'm going to leave all the other advanced options as default. Okay, and create dataset. So to create a table within your dataset, you need to click on the dataset name like this, and then in the new window, you just need to click on create table. Okay, now in the new prompt, this is where we choose how we're gonna load our dataset. So there are a couple of options. You can choose to have an empty table. You can choose to have your dataset directly loaded from the Google storage, cloud storage, or Google Drive, or other options that you see here. I'm going to upload it directly from my system. So I'm going to click on upload. Browse the file that you want to upload from here. And then in the destination, I'm going to choose the same project because I'm using the default project. In case you are not choosing the default project, browse it and then choose the correct project that you want to load your data into. Dataset name is powerlifting. This is what we created just now. The table name, I'm going to use open powerlifting, and then table type would be native. Don't worry about this. Keep this as default. Now, coming to the schema part, right now, the data that you are loading does not have any schema. So to explain what a schema is, it basically refers to the type of columns that you have in a data. Let's say you have 5 columns, and you know that these 5 columns, out of these 5 columns, 2 are a string and remaining 3 are number columns. Okay. But in order for SQL to understand that, you need to specify that schema. Okay. Now in BigQuery, there are 2 options. You can either specify the schema manually, or you can let BigQuery detect the schema automatically. So I'm going to do that only. I'm going to select auto detect and leave rest of the options as default. Okay. And I'm going to say create table. Now it has created a load job here and started loading the dataset. Now as you see, it has already loaded my data. And if I click on this new data that I loaded, it will show me the schema as well. So as you see, it's showing me all the columns that I have in that particular table and the type of data it has in here. You can also preview the dataset by clicking on this preview button here. And in case you want to check the details about the table name, you can do it from here. Now this name that is given here will be very useful while we are writing the SQL queries, and we'll get to see that in a while. Now I'm going to leave this lineage section for now because this is still in preview mode. Now let's just quickly load my second dataset as well. Now here's the second way to load a table. I'm going to click on this add data button here at the top. And now from this, I can choose local file. As I said before, there's an option to load the data from your Google Cloud storage, and it can also connect to other external sources such as MySQL database, PostgreSQL, BigLake, right? And all the others, right? So you can choose that as well. But for now, again, this is in my local system. So I'm going to choose local file. I'm going to choose the dataset as powerlifting and table name as meets. And then I'm going to again say auto detect and create table. So that is it, how you load a dataset into BigQuery. In the last video, we saw how to create a dataset and how to create a table within a dataset. Today, we will finally see how to write a SQL query within the BigQuery environment. We're going to start with one of the most basic SQL queries, and most of the time you'll be working with this SQL query, which is known as select statement. So this is how you write a SQL query within BigQuery. Okay. So click on the dataset that you created. So we're going to use the same dataset that we created last time, which was powerlifting. And within powerlifting, if you open up this drop down, you will find the two tables that we uploaded last time. So I'm going to click on this open powerlifting table and I'm going to come to this detail section. Now this is the table name or table ID that I have for this particular table, and we're going to refer to this table ID to write our SQL queries. I'm going to just click on this tab which says query, and within this drop down I'm going to say in a new tab. Okay, so what this will do is it will open up a new tab with a predefined query within it, and the query that it writes is a select statement. Okay, now SQL statements are very similar to English language. Okay, and that's what it makes it easier to learn. So in real world scenario or in a normal scenario, if someone walks into a store and in that store there is a rack containing a couple of items in it, if I have to communicate to someone in plain English to select few items from that rack, I will simply say that select item A, B, C from rack number this. Now SQL statements, especially the select statements, is exactly like writing English language. So you're going to just simply say select, then you're going to write a column name, and then you're going to inform from which table you want to select that column. Okay, so I know the table name is this, the table ID, and I'm going to use one of the columns, let's say name column, right? If I click on the preview section here in the table tab here, you can see the name of the columns that are there in the data set. So I'm going to say name, and I'll just say select name from this table. Now in BigQuery, when you write a SQL statement, it will also show you how much processing bandwidth it will consume. So right now this query that I've written here will consume 5.64 MB when it runs. Okay, so this can also help you determine whether you want to run a query or you want to optimize this further so that it can reduce your bandwidth allocation. Okay, so right now I'm simply saying select a column from the entire table. Okay, and if I run this, so to run this you just click on this run button here and it will start executing, and when it's completed it say query completed, and it will show you the result here in this bottom panel. So it's showing you the name column for that entire table. Now I can choose to have multiple columns selected instead of just one column. So let's say I want the equipment column and the age column as well. The way you do that is write a comma here and equipment, then comma, and then age. Okay, now I've made some alteration to the query. This query will process 9.71 MB when we run it. So I'm going to just again click on the query, click on run, and it will run the query for me. This time we are selecting 3 columns instead of just one. So in the results column, as you see, we are seeing 3 columns. Now let's say instead of just 1 or 2 columns or 3 columns, you want the entire table to be present there, or you want the entire table to be your output. So to do that, there are 2 methods. You can write each column at a time like we have written here. So we have written 3 columns. You can write the entire list of columns here. Or a better way to do that is simply write select star. Star simply means all. Okay. Now if you see, when we run this query, it will consume 35.58 MB of data. Now again, I'm going to, let's say write equipment here instead of the entire column. I just want equipment. And this query now is processing somewhere around 2.95 MB when we run it. In the equipment columns, there are multiple items which are written there. What I want to see is I want to see the unique list of items which are there in the equipment column. Right now, if I run this query, select equipment from this table, it will give me the entire list, but it will also have duplicate values, right? So let's see in the results. If you see straps, raw, right, and others as well, it's there, but it has duplicate values. I don't want that. I want unique values. So to do that, you just simply write another keyword, select distinct, and then the column name. Now if you see, you will get the distinct list of items which are there in that equipment column. You can choose to have multiple columns entered here. Along with the equipment, I also want gender distribution of those equipment usage. So I can simply say select distinct equipment and then sex from the table that is there, which is powerlifting. Now looking at the data, I can see that Strap's equipment is only used by male, not by female. Rest every equipment has been used by both males and females. So you see how we can use distinct to analyze different kinds of data sets. Now we're going to see how we can use different conditions or filters to further drill down your data set. And we will also see how we can use different operators to add more power to your filters. So let's quickly dive in. Now let's write the select statement so that we get more practice how to write a select statement. So I'm going to say select star from, you're going to mention the project name first. So here the project name is this. So Lithe Sonar. The IntelliSense feature will automatically suggest all the table names here. So I'm going to click this open powerlifting here. So it has automatically taken what I needed. But now we need to add more filters to this. Okay. So how do we do that? So after you write your select statement, which is select star from the table name or select the columns that you want from the table name, you write the where clause. Okay. And you say where age is greater than 25. Okay. Let's run this. Now, instead of greater than 25, I can also say less than 30, for example. Okay. And I'm going to run this and it will filter out all the values where the age column has less than 30 value in it. I can also say filter out everything where equipment is not equal to raw. Okay. And when you write a string, you need to write it within a quote. Okay. So it has filtered out the data for you. In this scenario, we only had one value to filter out, right? Now, what if you want to filter out your data on the basis of multiple values? Okay. So let's say I want to see all the row items where equipment has raw or single ply in it. To do that, we're going to use an operator which is known as in. I'm going to say, I'll open up a bracket. Inside a quote, I'll say raw and then again comma and then again the second value inside a quote, which is single ply. Now you see it has given me the correct results. Now mind you, when you enter the values here, this is case sensitive. So if you write raw like this with a small r, this will not fetch you the correct results. So when you enter a value into this condition, you need to be cautious that this is case sensitive. Now this is how we enter a condition on a single column. What if you want to enter a condition on multiple columns? Okay. So right now the condition is only there on equipment, but I want to add one more condition on, let's say, division column. You will add an additional operator to it. So we can add AND operator or OR operator here. So I'm going to say equipment in raw or single ply or division is equal to master 51 plus. Okay. And then I'm going to run this query again. Now, if we want both the condition to be true, I can use AND instead of OR and you run it. There is no row item which meets both of these conditions. So that's why it's not displaying any data set. So I think this is working fine. So I hope you understood how we can use where clause within a select statement and as well as utilize operators like in, equal to, not equal to, and, or, all of these things, right? Understanding of all these operators and how they work in sync with your select statement makes a big difference when you're analyzing your data set. Okay. Now, one last thing that I want to cover here today is how you sort a data set. Okay. So suppose I'm going to make it back to OR again so that we have some data set here. Now, once I get some data set, I want the data to be sorted on the basis of name. Okay. So all you have to do is you need to enter a clause which is called order by, and you need to enter the column name by which you want to sort. Okay. I want to say order by name, but by default, it will sort everything in an ascending order. So if I run this like this, it will sort everything in an ascending order. But in case you want something to be sorted in a descending order, so you just write DESC and you run it and it will sort everything on the basis of descending order. Now, sorting is a processor intensive activity. So if you have large amount of data, be cautious while running an order by clause. So today we're going to learn about two very important topics within SQL, which is limit and subqueries. Okay, and how we can use both of them together to answer very specific questions that you might be asked during an interview or during an analysis process. So let's just jump into it. Now, to begin with, let's start with the limit. So what is a limit statement? Basically, it's a way for us to get the top n items from your table. So for example, you want the top 10 row items from the existing table. You will use a limit statement. Now, in different database platforms, the limit statement might have a different name. For example, in SQL Server, you will use top instead of limit, right? And the place where we write top and limit are different as well. We will see how we can use limit in BigQuery because top statement is not valid in BigQuery environment. In BigQuery, we use limit. So let's say I have a table here and I'm using the same dataset that we've been using for the SQL series, which is open powerlifting dataset. So we're going to use the same table. And the problem statement here is I want to see the top 10 rows from this table. Okay, so this table has lot many rows in it. And out of those, I just want to see the top 10 rows. Now, there might be multiple use cases for this. First of all is when you're analyzing a big data set and you just want to see what kind of data that table has, you can use limit statement. The second use case is, which is usually asked in interviews, is how do you get the top 10 rows from a table and second top item from the table, right? So we'll see how to do that. But first, let's see how we write a limit statement within a SQL query. Okay. Select name from the project name, which is Lithe Sonar. And within that, I'm going to select this open powerlifting table where equipment is equal to raw. Out of this query, I want to see only the top 10 items. Okay. So I'll simply write after your where statement or whatever filters you have applied, whatever things you applied. I just want to say limit 10. And when I run this, it will only show me 10 row items from the top. I can also say limit 5 and it will only show me 5 row items from the top. It simply takes the top 5 items, right? So regardless of the fact whether those items are actually the top ones or not, it will take out the first 5 row items from the top, right? So in case you want to see the oldest people within this data set, so you'll use the age column and use the order by clause, which we used last time. And you'll say order by age. And I'm going to say descending. So I'm going to just simply write DESC. Now what it will do is it will first filter out the data for equipment raw, then order by the entire thing on the basis of age. And then it will give me the 5 items from the top. So now I know these are the oldest people within my dataset. And if you want to check, I can write age column here to see whether the output is correct or not. Now it will include the age column as well. Now if you see, the output was indeed correct. You might be thinking, what if I want the youngest people out of the lot, right? So all you have to do is just remove the DESC part, right? So it will order everything in the ascending order. And when I run this, it will give me the youngest people inside that table. Now let's understand another concept within SQL, which is known as subqueries. Now subqueries are important because it will help you churn out your data in multiple lots so that your end query or the way that you're processing your data becomes much more simpler. Now the concept of subquery is that I can consider this entire select statement as a single table. Okay, so I'm going to insert a bracket here so that my bracket encloses the entire select statement. And I can consider this entire thing as a table and I can consider this entire thing inside a where clause as well. Okay. So now my problem statement here is I do not want the oldest person in the lot. I want the second oldest person in the lot. So to do that, what I'll do is I'll insert this entire clause inside a where statement. And I'm going to say select name and age from open powerlifting. Okay. Let me just indent this a little bit so that it's easier to understand. Where equipment is equal to raw and name is not is equal to this entire statement. But because it's in a where clause and where clause expects one output or one column output, we cannot have multiple columns here. So I'm going to just remove this age from here. Okay. So the output of this entire select statement would give me just one column, that is name, right? And I'm saying that output should not be equal to this column. And one more thing to add here. After I've done that, I'm gonna say order by age descending and limit 1. I just want to see the top one, right? And when I run this, it will give me Dan Mason, right? And if you want to see if this output is correct or not, I'm going to copy this select statement. I'm going to add one more tab here by pressing on this plus icon here. I'm going to paste this select statement. Now instead of 1 here, I'm going to enter 10, okay? And run this statement. Now if you see, the first 2 row items were John Gilmer, and the second oldest person was Dan Mason. Now one more example is I can use this subquery inside a table reference as well. Right now we used it inside a where clause, but we can use it inside a table reference as well. So I can simply say, I'm going to enclose this inside brackets, and I'm going to indent this little bit, and I'm going to say select distinct name from this entire table and run. Now it has given me 6 unique list of items from that original list of 10 that we had in this select statement. So today we're going to cover 3 topics. First one is aggregation function. Second one is group by, and third one is aliases. The reason I'm covering all 3 of them today is that more or less all 3 of them are used in combination with each other. So without wasting any time, let's just quickly jump in. So to begin, we're going to start with aggregation function, and mainly we're going to cover 6 aggregation functions today. Okay, so let me just quickly write a select statement, and I'm not going to give any column right now. I'm going to write the from statement here, and I'm going to choose the table name, and the data that I'm using is the same data that we've been using, open powerlifting. Now instead of giving a column name, what I'm going to do is I'm going to write my first aggregation function, which is sum. Okay, and because this is a sum, it needs a numerical column so that it can sum up the values. Okay, so let's say total kg. Okay, this is one column that I have in my dataset, which has the total number of kilograms a person has lifted, right? So I'm going to apply some filters here. And I'm going to run this. So if you see in the results, it's given me the total kilograms this category of people with equipment equal to raw and age less than 15 have lifted in terms of kilograms. Now let's see another aggregation function, which is count. Now inside count, I can use either a numerical column or a categorical column. Okay, it doesn't matter. So I'm going to count the total number of names that I have for this category. Okay, so I'm going to run this, and it will give me a total number of count that we have in terms of names. The third aggregation function is average, okay, which is denoted by AVG. And I can again use the total kg column here because it's a numerical column, and for average, obviously you would need a numerical column. Now when I run this, I can see the average weight a person in this particular category, which is equipment equal to raw and age less than 15, is lifting. The fourth aggregation function is max. What this does is it gives us the maximum value within a range or within a particular criteria. So I'm going to say max total kg, and it will show me the maximum of total kgs someone has lifted. Similar to this, we also have min, which stands for minimum. And again, I can use the total kg column to see the minimum value in terms of kg that someone has lifted. Now, apart from all of these, we also have another aggregation function which is very useful, which is count if. Now, this is where you can apply a condition onto your count. So I'm going to remove this where clause from here. And instead, what I'm going to do is I'm going to say count if age is less than 14 and run. I can also add another clause here, and equipment is equal to raw. Okay. And it will give me a count of total rows that we have for this specific condition, which is age less than 14 and equipment equal to raw. Now, as of now, we were just getting the aggregation of a particular column. What if we want to see it adjacent to a certain column? Like for example, name. I want to see a person and how much kilogram that person lifted in terms of sum. To do that, obviously you might think that we can add a name column here, and besides that we can add a sum column, and within sum I can use total kg, right? But this will give me an error. That is because we have used the correct syntax at the select statement, but there is one key information which is missing here. We have to write a clause called group by, and in the group by, and I'll simply write name and then run. Okay, and I'm going to explain what group by does. Okay, now if you see, this is the output that I received. What it did was it gave me a summary of the entire data set. It summed up the total kgs for each person and then gave me the total sum of that person in the table below. And this is what group by does. It summarizes your data. Now, if you've used Excel pivots before, you will know that when you drag a certain column onto the pivot, it tends to summarize your data, right? So when you drag a certain column into the row section and then one column into the value section, it summarizes your data and then gives you a sum or count of that particular metric that you have dragged. Now, group by is the exact same thing within SQL. Okay, what it is doing is it's summarizing your data based on the column that you have given in the group by section. Now, when you're using the aggregation function alongside any other column, it is mandatory to write a group by clause. Otherwise, it will give you an error. Okay, but if you're writing only the aggregation function like this, then there is no need for a group by clause. Okay, so I hope you understood why and when we use a group by clause. Now, group by is not limited to just one column. I can add multiple columns to it. So let's say equipment, and when I'm adding an equipment here, I need to add the equipment in the group by clause as well. Okay, so again, a thumb rule for writing a group by: whatever columns that you have in your select statement, all those columns should be present in your group by as statement as well. Now, when I run this, it will give me two columns for name and equipment, and then it will give me the sum of total kgs for that particular category. Now comes the third concept that we will be discussing today, is called alias. Now you must have noticed, right, when we wrote this query, both name and equipment have proper header names, column header here, right? But the sum total kg column here has a default header name which is not that easy to understand, right? And someone looking at the dataset would not be able to understand what this column represents. This is happening because when you apply an aggregation function, SQL or BigQuery automatically assigns a name to that column header because you have not defined a particular name. Okay, in order to assign a name of your choosing, all you have to do is give it an alias name. Okay, and how do you give an alias name? You just write as and give it a name. Let's say total kg underscore sum. Okay, and then run. Now if you see, the result that it gives out will give me both name and equipment in the column header. Alongside that, it will give me the new column header that I've given, which is total kg underscore sum. So as you see, all three concepts that we discussed today are some way or other used in combination with each other to get a certain output. Couple of videos back, I showed you how we can use where clause to apply filters onto your SQL queries and eventually apply filters to your final output. Now we're going to take one step forward from there, and I'll show you today how we can use wildcards and like statement to power up your where clause. So let's write a select statement first. So I'm going to say select name from, again, I'm using the same table as before. Now I'm going to write a where clause here. Okay, and I'm going to say name. Now, up until now, you saw how we can use an equal to sign or a greater than or less than or greater than equal to sign or not equal to sign to get our output or get our filters into your where clause, right? Now, what if you do not know the exact value that you want to find? Instead, you want certain combinations of letters in a certain string. In layman terms, you want to apply a contains filter instead of an equal to or not equal to filter. Okay, so you just wanted to identify if a certain string contains a certain letter at a certain position, then you would need that result, right? So in order to do that, SQL gives an option which is called as like. Okay, so I'm going to say name like, which is again a keyword, and we're going to use like with certain wildcards. Okay, and essentially we're going to cover two main wildcards today. First one is a percentage sign and second one is an underscore. Okay, and I'm going to explain the relevance of each one of them with an example. Now let's say you want to find every string inside your table which starts with the letter P and can have any number of letters after P. I'm going to write P and then percentage. So here I'm instructing SQL to give me every word which starts with the letter P and can have any number of letters after that. So if you see, the output says Peyton, Peter, Pam, Paulo, Pamela, right? All of these are starting from the letter P but have multiple numbers of letters post that letter. Now comes the second condition. You want all the row items from the table which ends with the letter Y. Okay, so in that case you will have percentage before Y. Okay, and mind you, this is case sensitive. So for SQL, a capital Y and a small y are two different things. Okay, now this simply is asking SQL to give me all the outputs which can have any number of letters in that string but ends with the letter Y. Okay, and when I run this, it will give me this output. If you see, all of these outputs are ending with the letter Y but have various number of letters within the string. Now what if you want to identify all the strings which have E as the second letter? So to do that, you will use an underscore sign. Now this simply means the string should be starting with some letter but the second letter should be Y. If you do not give any other wildcard here, it will simply imply that the total length of the character should be 2, right? But I don't think there is any name with just 2 letters here. So I'm going to write a percentage sign, which means it starts with any letter, second letter should be E, and then it can have any number of letters. Okay. Now if I run this, observe all the second letters are E here. Similarly, you can use a combination of underscores and percentage to get your desired output from a particular table or a column, right? And this is not just limited to just one underscore. I can find out the third character as well. So I'll enter one more underscore here, and let's say I'm going to enter a Y here and run. It will give me all the characters or all the strings which has Y as the third letter and can have any number of letters after that. So if you see Peyton, Y is in the third position, Alice, Y is in third position, and similarly, right? So I hope you understood how we use like and wildcards together to power up your where clause. Now I'm going to write a SQL statement here, and it will be a select statement from the same table that we've been using so far, open powerlifting, and the column name would be name and sum of total kg column. Okay, and I'm going to call this as total kg underscore sum. Now obviously the statement is not completed here. I need to enter a group by statement because I'm using an aggregation function alongside a categorical column. So I'm going to say group by and name. Okay, and if I run this, I get a result here with all the names which are there in my table, and data is summarized on total kg column based on sum for each person. Now here's the requirement. I want to filter out this data and I want to say show me only those values where the sum of total kg is more than 500. Now you might think that entering a where clause here would solve the problem like this, right? Where total kg underscore sum is greater than 500. But here's a problem. Total kg sum is not recognized because this particular alias name is yet to be run. SQL does not recognize this particular name right now. And even if I write the statement like this, where I put the aggregation column right inside the where clause, SQL will not allow that as well because aggregation functions are not allowed in the where clause. So the only thing remaining to do is, once you have grouped the data, you need to apply your clause. But where clause is not allowed to be used after your group by statement. So let me show you. If I write where here, and even if I write total kg underscore sum, this will still give me an error, because where clause is only allowed to be used before your group by statement and after your from statement. So in this scenario, only option that you have left is to use a keyword called having. And having is meant to be used after your group by statement, not before it. Okay. So when I run this, it will first summarize the entire table for me using the group by statement. And after it has summarized, it will apply that new filter that I gave, which is total kg sum is greater than 500 using the having keyword. So I hope you now understand what you need to do when you have to apply a condition before the group by clause and after summarizing a data using the group by clause. Today we're going to learn about a new topic which is used when you want to combine two tables together vertically. So what do I mean vertically? In case you want to append the results of two or more select statements together and input all those data in a single table, then you will use a concept known as union. And we're gonna see how we can use union to, first of all, combine dataset from multiple sources into a single table, and how we can also remove duplicates while doing so. Okay, so let's just quickly jump into it. To demonstrate this topic, I've created two tables here. First one is OPW female and second one is OPW male. And these two tables contains the same data that we've been using, which is open powerlifting. Only difference being I've splitted the data into male and female. So we're gonna write a select statement referring to each of those tables and then combine the data set from both of those tables. Okay, so I'm gonna say select name and age from OPW female where equipment equal to raw. And then I'm gonna write another select statement where I'm gonna say name age from this time OPW male where equipment is equal to single ply. Now to combine these two select statements, we're going to use a keyword known as union all. Now what union all does is, regardless of the fact whether these tables have duplicate values or not, it will append everything together. Okay, and if I run this, it will append all the data set that has been returned from both these select statements. Now there are three basic rules while writing a union statement. First of all, the number of columns that you have in all the select statements within which you want to use union should be the same. Right now I have two columns here and I have two columns here, right? So both the select statements had two columns. Second rule, the order of the column should also be the same. I'm using name and age here. At the bottom table also I should have name and age. So the order also matters. Now the third thing is the data type. Whatever column names you're using, the data type should also be the same. So you cannot do that in the first select statement you have an integer value and in the second statement you have a text value or a string value, right? So that would not work. It will give you an error. So whatever data type you're using in the first select statement, the second select statement should have also the same data type for both or all the columns. Now when we ran this, as I said, union all does not consider duplicate values, it just appends everything together. Now what if you want duplicate values to be removed from this? So for that, I'm going to make a small shift in the query here. Instead of using OPW male here, I'm going to write OPW female only. Okay, so that now when someone runs this, there are high chances that records written from both the select statements have some duplicate value in it. Okay, so to eliminate that chance, what I'm going to do is, instead of union all, I'm going to use union distinct. This will remove any duplicates from the results and give you the final output. Okay, so right now I have 40,000 records here, 40,085 records. And just to check if it worked or not, I'm going to write union all again here and I'm going to run this. And if you see, I have 74,974 records if I am not using union distinct. So I hope now you understand how we can club multiple select statements together or append results from multiple select statements together vertically. And just to add, union is not limited to just two select statements. I can write as many select statements as I want by just writing union all like this and then entering my third, fourth, fifth select statement, right? Only thing that you need to take care is the three rules that I mentioned, which is number of columns should be the same, order in which you're writing the column should be the same, and the data type should be the same. Often while doing data analysis, we come across a situation where the information that you need is often splitted in multiple tables, and you need a way to kind of club them together. Now, in the previous video, we spoke about how we can combine or append data vertically from multiple tables into a single table. But now let's understand how we can join data together horizontally. Now, the concept related to join is very important for you to understand. So we're going to start from the basic. Let's take an example. We have two tables here. First one is meets and second one is open powerlifting that we've been using in a couple of our videos now. Okay. Now in the meets table, we have a couple of information regarding meet ID, right? So where that particular athletic meet happened and what was the federation that hosted that particular meet, what was the country where that meet happened, and some other information, right? Then we have open powerlifting, wherein we have some more detailed information, right? Wherein within each meet, how many players were there, what kind of equipments they were using, their gender, age, and all those things, all those nitty-gritties. Now, what if I want to do an analysis and create a single table where I need the names and equipment from this particular table, which is open powerlifting, and I want the federation column from this meets table. Now, this is where SQL joins comes into action. There are four main types of joins. First one is a left join, second one is a right join, third one is an inner join, and fourth one is a full outer join. Now let's understand all these joins with a visual example. So here I have two tables. On the left hand side I have table A and on the right hand side I have table B. When I apply a left join, I'll get every information available within table A, and whatever information is matching in table B, I can fetch from table B, and anything which is not matching will return as null. Now, second one is the right join. In the same example, if I apply a right join, I will get every item from my table B and only the matching row items will be returned from table A. Now comes a third join, which is an inner join. Now here, when I apply an inner join, it will only return only the matching row items between both the tables. So let's say I have A, B, C in the left side table and I have only A and B in the right side table. The final output will only have A and B because A and B are the only row items which are matching and which are existing in both the tables. Then the last join is full outer join. This is where SQL will return all the values from table A and table B. I'm assuming that you get a basic idea of what join means. Now, to solidify your understanding, let's just jump into an example that we have here. We'll be using these two tables, which is meets and open powerlifting, to demonstrate an example of join. Now, here is the requirement. I need a table where meet ID is 20, 62, and 100, and I want column name, equipment, and division from open powerlifting, as well as I need an additional column from meets, which is federation, to be included in my final output. Okay, so I'll be using a join, and I can use a left join here. So this is how it goes. I'm going to write a select statement, select from Lethe open powerlifting, and I'm going to assign it a alias so that it's easier for me to refer to the columns from this table. Now, in joins, you need to make sure that while referring a column, you need to refer its table name as well. Otherwise, SQL will get confused whether to use the column from the left table or right side table, right? So this is how it goes. I've assigned a alias name to this table, which is PW for open powerlifting. And now I can say PW dot name, comma, PW dot equipment, and PW dot division. What I need to do is I need to join this table with the meets table, right? So for that to happen, I'm going to say left join meets, and I'm going to assign a alias to this, empty. And then the final statement here is on. So basically, whenever you join something, you need to mention which table you want to join, and you want to mention the unique key which is used to join those two tables. In my case, it's meet ID. So I'm going to say pw.meetid is equal to empty.meetid. So I'm saying join these two tables on the basis of meet ID in PW and meet ID in empty. Okay. Now this is where Alias helps a lot, because otherwise I would have to write this entire thing before mentioning the meet ID clause. Now I can safely add another column to it, which is empty.federation. Now the join has been completed. Only thing left is to apply that condition where pw.meetid in 20, 62 or 100. And then I'm going to run this. So as you see, I've successfully joined both open powerlifting and meets table to get a final output where I have 3 columns from open powerlifting and 1 column from meets table, which is federation. Now when I applied this join, it gave me everything from the open powerlifting table, and whatever it found matching from the meets table, it populated here. Now in the same case, if I change this left join into a right join, then it will return everything from the meets table and only return values which are matching in open powerlifting table. Okay. Now here comes an important concept to understand. Whenever we are joining a table, right? In this case, because my meets table has one value for each meeting ID and open powerlifting has multiple row items for the same meet ID, this particular join represents a one-to-many join. Okay. But instead of this, if I write a left join here, then this represents a many-to-one join, because open powerlifting has many values for one meet ID and meets only had one row item for one meet ID. So which represents a many-to-one. Okay. Now in the same scenario, if I just change it to an inner join, this will return everything which is matching in both the tables. Okay. Any value which exists in only one of the tables will not be returned. Similarly, if I write full outer join, this will return everything in both the tables, regardless of the fact whether it found a match or not. Today we're going to see a concept known as case statement, and we will see how we can use case statements to build logic within the values that you get in a new column. This is very similar to if-else statements that we have in other programming languages, and we will see how we can use the logic building capabilities of case statements to create a new column and certain values for that column. So let's quickly jump into it. So I'm going to write a select statement here. Now I would like to create a new column here. Okay. And the condition for the new column would be the column will be defining the category of athletes that we have in the open powerlifting table. So if the athlete is less than 12 years of old, then the value that will be coming in that column would be very young. If it's between 12 and 16, then it will be young. If it's between 16 and 35, then it will be adult. And if it's more than 35, then it's old. Okay. So how do we do that? We will use the case statement, and the keyword for using a case statement is case. Okay. And you will write when age column is less than 12, then I would need very young. When age is between 12 and 15, then young. When age is between 16 and 35, then adult. And then at the end, we will just say else old. Okay. I'm going to indent this little bit so that it's easier to read. And you end a case statement by the statement end. Okay. And I'm going to give an alias to this new column as age category. Okay. And that's it. Let's run this. As you see, we have got a result, but I would like to add one more column to it, which is age column, so that we can verify whether our results are correct or not. Now, if you see, we have successfully assigned different categories to the age brackets that we have for each athlete. This is how you can assign different kind of logics within your case statements to have a variety of values for a single column. Now, case statement is not just limited to less than or equal to sign. You can use any number of operators within case statements, including like, so that you can find an approximate match within a particular column and assign a certain value to it. Now, one small thing that we are yet to see in BigQuery is how we can extract this data. There are multiple ways we can extract this data, right? First of all, we can save this query so that anytime anyone wants to run the query again, they don't have to write everything again. They can just simply click and run it. The way you do that is to, once you write the query, just click on save and click on save query. There's another option here which is called save view. We will review this in a future video, but for now, just understand if you want to save a query, you can just click on this save query to save it. Now, if you want to extract this data into a table instead of a query, all you have to do is just click on this save result here and click on BigQuery table. This will add this query to your table panel here. And when you click on this BigQuery table here, it will give you a prompt so that you can select a dataset and write in the table name that you want to assign to that particular data. Okay. But right now, what I'm going to do is I'm going to extract this into a CSV. And the way we do that is just click on this save result here and click on this CSV file, local file. Okay. Now results are being fetched and it will be automatically downloaded to your local system. While saving to the CSV, BigQuery has shown a limitation here, which is it was only able to store a certain number of rows like you see in this prompt below. Now, in case you have a big table, you should consider storing your data in a BigQuery table instead. Okay. I'm going to open the CSV file so that we can just quickly check if all the categories assigned by the case statements were correct or not. Okay. Okay. So here is a CSV file that we just downloaded. And if I just put a filter here, so anything below 12 was assigned as very young. Anything between 12 and 15 were assigned as young. Now anything between 16 and 35 were assigned as adult, and anything more than that is assigned as old. That is the else statement that we wrote, right? So this proves that the case statement is working just fine. Before we end today's video, I would like to share two observations that I saw while I extracted the dataset. If your data have decimal values in them, then writing the conditions like this might create a problem because the first condition was 12 and 15 and the second condition was 16 and 35. So if you have a number between 15 and 16, let's say 15.5, then that will automatically go to old, which is not something that we would want. So to avoid that situation, you can just write it as 15. SQL will assign 15.5 in the adult category. Secondly, if your data has null values in it, then obviously you would want to handle that first inside your when statement. So just write when age is null, then NA. And if I run this, it should give me all the correct values, even if I have null values or decimal values. Having the knowledge to create an array is a skill that is valued in every programming language, and SQL is no exception, especially when you're talking about BigQuery. And in addition to that, using that array to create a table is also very important because that gives you the power to use that array in multiple SQL queries. So today we're going to see how exactly we can do that in BigQuery and also learn about a function which is exclusive to BigQuery environment, which is called Unnest, which we will be using to create a table from an array. So without wasting any time, let's just quickly jump into it. So to start with, this is how you create an array in SQL. You initiate your array with a square bracket, similar to every other programming language. And within that, you can enter your values. So I'm going to enter a couple of values here. And this is an array that I have created. Now, by in itself, it does not hold any relevance because we need to write some kind of query to make use of this array. So if I write select this array, this will give me a simple output with all these values placed inside a column in row values. I can also assign a column name and run it again, and it will assign that column name accordingly. Now, what if you want to create an array of integers with 1000 row values? I mean to say from value 1 till 1000, right? You would obviously not type it manually like I typed this array value, right? So BigQuery gives us a function known as generate array, okay? And the parameters that it takes is the starting point of your array, the end point of your array, and by how many steps you want to increment it. So I want to increment it by 1. That means first value will be 1, second value will be 2, third value will be 3, and so on and so forth, right? Then I would write 1. In case I wanted to increment by 2, then I can write 2. So first value will be 1, second value will be 3, third value will be 5, and so on and so forth. Now if I run this, it will create a column called int array, and it will have 1000 records in it. As of now, this is just an array. It is not a table yet. I will not be able to run specific SQL operations on this particular column without converting it into a table. So how do we convert this into a table? To convert this, we use a function called Unnest. So the way you use it is, I'll just write select star from, okay, and this is our basic SQL syntax that we use. And alongside this generate array, I'm going to write Unnest and open up a bracket. And when I run this, this will consider this entire piece as a single table. Now I can write my conditions here like a normal table where int array is less than 500, let's say, okay, and I run this. So it will give me value till 499, as you can see here, okay. Also, now I can insert this entire thing inside a subquery, right, like this, and write select int array and then a new column which will be a multiple of int array, and I'm going to multiply it by 3, and I'm going to name it as, let's say, new int array, and then write from this entire thing, okay, and then we can run this. This will give me 2 columns. One would be int array, second would be the new int array that we created. I can invoke one more function within BigQuery, which is known as struct, to create a 2-dimensional table. Right now the table that we created had only 1 column, but now we can create a 2-dimensional table with using the struct keyword. So I'm going to say select star from Unnest, then you open up a bracket, and within a bracket, because Unnest accepts only array values, I'm going to insert a square bracket here, and within the square brackets I'm going to write a function called struct which accepts a key value pair, which means I need to mention a value first. So I'm going to say a as name, so name would be my column name, and 20 as age. Now this would be my second column, which is age, okay, and these are the values that I'm going to assign to each column, 20 and a, okay. And now I'm going to add one more row item. To add another row item, you don't need to mention this age and name again. All you have to do is just insert a comma here and open up a bracket and again write b and then comma 34, right? And if I run this, this will give me an output like you see here. I have 2 columns, name and age, and both of them have 2 row items representing the values that are assigned to each column here. I would like you to point your attention towards this small table here, which represents the various SQL commands categories that we have. Up until now, we were covering length and breadth of the select statement, which is part of the DQL family of SQL commands. The DQL part of SQL commands is something that can be run within BigQuery using the free default account that you create using your Google account. But to run any DML queries, which includes update, insert and delete, you would need to set up a billing account. Now don't worry, if you're doing this for a learning purpose, Google already gives us $300 free credit for 90 days so that you can practice these concepts without paying a single dime to Google. All you have to do is set up a billing account, and the way you set up a billing account is by clicking on this small button here which says upgrade, and this will take you to the billing page wherein you would have to insert your credit card details, and then it will just verify your credit card and create your trial account. Now, unless you opt for a paid account, Google will not charge you anything. After the 90 days, it will simply get deactivated. So you don't have to worry about Google charging your credit card after 90 days. Now, since that's out of the way, let's quickly jump into today's topic. Today, we will be covering the update statements within the DML category of SQL commands. And we will see how you can use the update statements to manipulate your tables as a part of data cleaning activity. The dataset that we're using today is the same dataset that we've been using so far, which is Open Powerlifting, and you can download the data from the link in the description. Now in the Open Powerlifting data, we have a column here which says division, right? And in the division column, I have a lot of values here, but I also see one null value here. Now from a data processing point of view, I do not want a null value to be shown in my division column. So I would need a way to change this value to something that I would prefer. Let's say not applicable, okay, instead of a null value. So how do we do that? I'm going to open up an editor window here and I'm going to write a SQL statement. Now you've seen how we write a select statement. This is how we write a update statement, okay? So keyword for update is update. You write the table name, and in this case, this is Open Powerlifting. So I'm going to select this one. The second line of code that you write in an update statement is set, okay, where you're setting a value for a certain column. And I'm going to say set division is equal to not applicable, where now I'm asking SQL to change the value of division to not applicable where a certain condition is meeting. So in my case, where division is null. And I'm going to run this. Now, because it's an update statement, it might take some while depending on the dataset and how heavy it is. But after it has executed, it will show you a message like this. As you see here, this statement modified 15,844 rows in Open Powerlifting, which means there were 15,843 rows where we had null values in division. Okay. And if I go back to my Open Powerlifting, go to preview, I will not be seeing that null value anywhere now. And just to check if it has actually removed my null value or not, I'm going to write a statement which says select distinct divisions from Open Powerlifting. Now this is a new way where you can run a specific query within the same editor window. All you have to do is just select the statement that you want to run and click on run. Okay, it will run just that portion of the query. Anything else which is not selected, it will simply ignore. Like for example, in this case, it is ignoring the update statement that I've written at the top and just running this select statement here. I'm going to just run this and it's going to give me some results. Now there are a lot of results which were fetched. So just to filter out something, I'm going to just say where division is null. Now ideally, there should not be any record which have null in it. So it should return a 0 record. As we expected, it is now showing there is no data to display. So our update statement worked just fine. Now update is not limited to just one column. I can set multiple columns where a certain condition is met. Like for example, I have certain row items where squat 4 kilo is null and bench 4 kilo is also null. So I'm going to simply say set squat 4 kg is equal to 0. And while you're setting up the values, just make sure that you adhere to the data type that particular column consists of. Okay, so that you don't create any problems for future queries. Now I know that squat 4 kg is a float, right, which is a number type column, and I can assign a number type value to it, not a string. Okay, so I'm going to say squat 4g is equal to 0, and I'm going to also say bench 4 kg is equal to 0, where division is equal to not applicable. Okay, and I'm going to run this. And again, this has modified 15,843 records. I'm going to just write a select statement in the new editor window. Select star from powerlifting where division is equal to not applicable. Now, as you see, it has updated squat 4 kg and bench 4 kg to 0 wherever we had null values. Okay. So this is how you use an update statement. And update statement really helps a lot when you're analyzing your data and finds out an anomaly. And obviously, I would not suggest you running the update statement on the raw data. Always create a copy of your main table and work on that table so that in case you want to move back or see what was the original data set, you always have an option to do that. We're going to cover the second item in the data manipulation language, which is insert statement. So for today's example, I'm going to use the meets table here. And as usual, links will be in the description where you can download this dataset and follow along if you want. Now, if I go to a preview section of this dataset, I see that there are multiple columns here. Okay. So the task at hand here is I want to insert a new row item within this table using a SQL statement. So whenever you want to insert a data set into an existing table, you will use a statement called insert. And this is how we write an insert statement. So I have opened up an editor window here and I'm going to write keyword for insert statement, which is insert. I want to insert a row item into the meets table. So I'm going to say insert into meets. Then in the second line, you need to enter values and open up a bracket and start entering the values for the new row. Now the rule for insert statement is if you are entering values for each and every column within your table, then you can just directly enter your values like this. Just keep in mind the order of the column. Order of the column cannot be disturbed. So the first column is meet ID and then meet path, federation, date, meet country, meet state, meet town and meet name. So in total, I have 8 columns. So when I'm entering a values like this, I need to enter 8 values. So I'm just going to enter a random value. Please make sure that you are adhering to the data type for each of the columns. And if you have any doubt, you can always go to the schema and check what type of values that column have. So meet ID is an integer. So what I've written is correct. Then we have a string. So for now, I'm going to just randomly enter some value. Now I have entered all the values. The first one is an integer. Second and third one was a string. Fourth one is a date. So that's why I've entered the date like this. Make sure you follow the format as it is, which is there in the dataset. For example, if I enter the date in DDMMYY format, this will not accept because in the dataset, it is in YYMMDD format. Okay. So you need to enter it in the same format. And then remaining all of them were string. Now, if I insert this by running this query, the prompt here says this statement added 1 row to meets. And just to check if it worked fine, I'm going to write a select statement star from meets where meet ID is equal to 999. Okay. And I'm going to select this statement and run it. And as you see, I've successfully inserted this row item into the table. Now, what if while inserting values into the table, you do not want to insert values for all the columns? Instead, you want only couple of values to be inserted in couple of columns. So what will you do then? Solution for that is very simple. After you return insert into, just open a bracket here and enter the column name where you want to insert your values. So let's say example, I want meet ID, I want meet country and federation to have some values. Now, if you see when I entered the column name, obviously the order of the column is not correct, but that is perfectly fine because now you're specifically mentioning the column headers first and then giving some values. So I'm going to remove everything else from here. And I only need 3 values here, which is meet ID, meet country and the federation. And I'm going to just run this query now. Now let's check if it's working fine or not. I'm going to select the below statement and run it. And when I ran the select statement, it is now showing 2 row items because both of them have the same meet ID. But one of them have only values in meet ID, federation and meet country. Remaining all the columns are null because we have specifically said that I want to enter values for only these columns. If you notice, the order of the column did not matter because in the table, after meet ID, we have federation and then meet country, right? But since we have mentioned the column header here, the order does not matter. It will follow the same order that we have mentioned here and enter the value one by one for each column header. We're going to see how we can actually delete any row items from your table using the delete statement. Now, before we begin the video, I want you to be absolutely cautious while running delete statement, because recovering our data after you run a delete statement is a tricky affair, right? So be very cautious when you're running your delete statement, because you're actually deleting row items from your data, which can have a unforeseen impact or unwanted impact on your final outcome. So without any further ado, let's jump into it. Now, before running the delete statement, let's identify the condition on which you want to run a delete statement. Okay. So I'm going to write a select statement here. And if you remember, in the last video, we inserted 2 row items in my table with a specific meet ID. And if I remember correctly, the meet ID was 9999. Okay. So I'm going to say select star from meets for the table where we inserted those row items, where meet ID is equal to 9999. Okay. And I'm going to run this. Now, if you see, I've got this result wherein I've got 2 row items, and what I would like to do is I would like to delete the row item where the meet path is null and the meet ID is 9999. Okay. So how do we do that? So this is how you write a delete statement. So I'm going to write delete, which is the keyword for starting a delete statement. And then you enter the table name. And in this case, my table name is meets. Okay, so at this point, I wanted to quickly highlight a point here. Although in BigQuery, it accepts writing a delete statement without a from clause, in a couple of database systems, it requires the from clause when you're writing a delete statement. So as a SQL standard, it is always a best practice to write a from clause between your delete and your table name. So you should write your statement like this: delete, from, and then the table name. So if that's clear, let's get back to the video. And in the second line, I'm going to say a where statement and say meet ID is equal to 9999. And then I'm going to use an operator, which is AND operator. And I'm going to say meet path is null. Okay. So I'm instructing SQL to delete everything from meets table where this condition is met. That is, meet ID is equal to 9999 and meet path is null. Okay. So I'm going to run this. And as you see, the intimation is saying this statement removed 1 row item from meets. So let's just check if it worked or not. So I'm going to again write a select statement. And I'm going to say from meets, where meet ID is equal to 9999. I'm going to select this and then I'm going to run. And ideally, I should only see 1 row item, which is exactly what we are seeing here. So which means our delete statement has worked just fine. So I hope you understood how we can write a delete statement. The concept is really simple. You can use as many conditions as you want. Whatever we have learned so far in terms of operators and in terms of where clause, you can apply all of them here and arrive at a certain logic, which will then be used to finally delete a particular row item from your table using the delete statement. We're going to look at a function which is known as window or analytics function in SQL. Now, by definition, what this type of function helps you to do is isolate a section of a table and carry out some mathematical operations on that particular section. Now, how will this be important for us? We will just see in a while. So before we get into the actual function, let me show you the dataset that we'll be using today. And the link will be in the description in case you want to follow along. This dataset is a sales dataset for each country, and this is a CSV file. Now here is the requirement for today. Now in this sales dataset, I have a column called segment and I have a column for country, and at the end I have a column for sales. The first part of the requirement is I need to aggregate this data and summarize in a way that I can see the total sales done by each segment for a particular country. Now after you've done that, the second part of the requirement is I would like to identify the total percentage a particular segment holds in comparison to the total sales done by the entire country. Okay, if that's clear, let's just quickly move into our editor window. I'm going to press this plus icon here and open up a new editor. And in order to summarize the data on the basis of segment and country, that is very simple. We can just simply use the group by clause to do that. So this is how we do that. Let's write a select statement, select, and I'm going to say from sales. And once I've written that, I can write in the columns. Okay. And the reason I wrote the table name first was because it helps me pick the column names from the intelligence feature in BigQuery. So now I can write segment, country, and I need an additional third column which will aggregate the total sales. So I'm going to say sum of sales as total sales. And then at the end, I can add a group by clause here, segment and country. Let me just run this. Okay, I have some results here, but the results are a bit jumbled up. So I'm going to just apply order by clause here. So order by first country, and then I need to order by total sales. And let's order the total sales in a descending order so that I have the segment which has the maximum number of sales at the top. So run this again. Okay, now I have the result what I needed. So I have the segment here, I have the country, and it is sorted on the basis of country and the total sales. So if you see, first we have the country and then total sales is sorted in a descending order. Now the first part of the requirement is completed. Now the second part is I want to create a column here, an additional column which will have the percentage for each segment for a particular country. So for that to happen, what I need to do is I need to identify a way to get the total of a particular country. In this case, let's say total sales done by Canada, and then divide this number with that total sales. So how do we do that? So let's create a subquery here. I'm going to indent this a little bit so that we know this is part of a different table. I'm going to put this inside a bracket, and at the top, I'm going to say select from. And in this select statement, I'm going to write star because I need all the columns that I already have in the below table. But apart from that, I also need a column which will calculate my percentage. Okay. And how can I calculate my percentage? It can be done simply by dividing my total sales column by the grand total for a particular country. And to do that, this is where we're going to use our window or analytical function, sum of total sales. So what analytics function helps us to do is isolate a section of a table and then apply some mathematical operation onto it. So we've already selected which operation we want, which is sum, right? But to apply that onto that section, we need to create a section, right? To create that section, it's going to start with the keyword over. We'll open up a bracket. And inside the bracket, you can write partition by. This works similar to a group by, but we are operating at a row level basis. We're going to partition this entire section on the basis of country. And I'm going to just put this entire thing inside a bracket as PCT sales. Now let's run this. Now if you see, it has calculated the percentage for each row that I have in this final table for a particular country. And if you want to see what's happening here, I'm going to include one more column here, and let's copy paste this thing. And instead of calling it PCT, I'm going to call it country sales, and I'm going to run this. What this has done is it has created a section which contains a country at a time because we have partitioned it by country, and this country sales will have the same total wherever we have Canada, and same case for United States. We have the grand total for United States for all the row items in country sales. So for each country, we will have the grand total specific to that particular country. We're going to continue our journey into the window function. So in the last video, we saw how we can use window function to create a section or isolate a section of a table and then perform some mathematical calculations on that section. Now, to continue on that journey, we're going to today see how we can calculate moving averages using this same concept. The data that I have today is a stock data. I downloaded this from Yahoo Finance, and if you're interested, the link will be in the description. You can download it from there. This is an Apple stock data, and what we're going to do is we're going to create a moving average on the closing price that we have in this data set. Okay. And we're going to use the date column and the closing price column to arrive at a final output. So this is what we're going to do now. I'm going to open up an editor here. Let me start by typing a select statement from Apple stock. Okay. And I'm going to need two columns from that. First one is a date column and second one is the close column. But now I need an additional column, which will be my moving average column. Okay. And for starters, let's start with a 7-day moving average. Okay. So what we're going to do is we're going to, first of all, if you remember in the window function or analytic function, we need to first define what type of mathematical operation we would like to conduct. Now, obviously this is a moving average. So we're going to use an average. Okay. So AVG, and I'm going to use the column close. Now to start our window function, I'm going to write over. Now after you write over, I'm going to write the order by clause because I want the section that I'm creating to be ordered ascending by the basis of date column. Okay, so I'm going to say order by date. Now once we have ordered the date column in an ascending order, we have to create the actual section on which that ascending order will work. To create a section, this time we would not be using the partition by clause like we used in the last video. Instead, I'm going to use inbuilt predefined SQL keywords, which will be, in my opinion, is something similar to a plain English, which will help us create a dynamic section for 7 consecutive rows. And the keyword starts with rows between 6 preceding and current row. And I'm going to name this entire thing with an alias called as, let's say, moving average 70. Now, if I explain this line to you, all it's saying is create a section with 6 preceding rows and current row. So if you add up 6 preceding and the current row, which eventually means 7 rows in total. But the work here is not done. We may have ordered the section that we have created, but we have to order the entire table as well. So I'm going to write an order by clause at the end as well, so that my entire select statement can be ordered as well. Now I'm going to run this. Now if you see in the result, the first one will be same because there is nothing before this row to calculate. That's why this item is the same. But this one says 171,114,997, which is nothing but this row plus this row divided by 2. Then if we move forward to this row, this simply means this plus this divided by 3, and so on and so forth until it finds 7 preceding rows. Okay. Now I'm going to extract this data so that we can check if our results are fine or not. I'm going to click on this save results and then click on this CSV local file. Now I have opened up my CSV file and let's check if it's working fine or not. So this one is the same number. This number should be an average between these two. So if I check here, this is correct. This is an average between these two. This should be an average between these 3, which is again correct. And I move to the 7th row. Now if I look at this number, this should have the 7-day moving average. So if I select these 7 row items, 168.057, this is exactly the number that we're getting here. Now, when I move on to this row, this should again have the 7-day moving average, and they should have moved one cell downwards, right? And should have the latest 7 rows. So just select these 7. And if I look at the average, this is 167.37. This is exactly what I'm getting here. So which means the moving average is working just fine. Coming back to this query, let's say I want to calculate a 15-day moving average. So for that to happen, what I'm going to do is, again, I'm going to create a new column, and let me just expand this section a little bit. I'm going to paste this exact line here. But because we need a 15-day moving average, what I'm going to say is 14 preceding rows and the current row, which makes it 15 rows in total. And I'm going to rename this as 15-day, and I'm going to run this. And as before, this will also fetches the correct result for us. This time, the new column has been created for a 15-day moving average. So I hope you understood how we can calculate moving averages using the window function, which is very useful, especially when you're dealing with the data which contains a time series value. So before we get into the BigQuery environment, I just want to quickly show you this Excel file where we have the same dataset that we used in the last video. I want to sort this data in an ascending order first, and then I would like to create a new column by the name of previous close. And what this field will have is the prior day closing value in it. So obviously, since this is the first day, first one will be null. And the second day onwards, this will have the previous day value in it. Like this. Okay. Till the end. Now doing this in Excel was pretty straightforward. But what if your data is a big data and it exists in the BigQuery environment or a SQL database, then how will you do this? Because there should be a way where you can identify at each row what was the value in the previous row. Now, this is what we're going to achieve today in SQL by looking at a specific function which is part of the window function within SQL known as lag. So let's just quickly jump into BigQuery and see how this is done. Okay, so I'm in the BigQuery window now, and I can see the dataset here, which is the Apple stock data. Now, let me open up an editor window. The first thing that I would like to do is I would like to write a select statement and select the columns that I need. In this case, I need the date column and I need the close column from Apple stock. But I would like to create one more column by the name of previous close. And to do that, I'm going to write a specific function called lag, which is part of the window function of SQL. So I'm going to say lag, and the parameter that it accepts is the column name where I want to apply the lag function. So in this case, I want to apply the lag on the close column because I want the previous close value. Then obviously, because this is a window function, we're going to write an over clause here, and within over clause, I'm going to write order by, because I want to first order the section that it's creating on the basis of date column, and I'm going to name this as previous close, and I'm going to order this entire table by date column. Now if I run this, if you see, what this has done is it has first of all sorted the entire data set, and then it has also sorted the section that it created using the over clause, and finally got the result which was just prior to the current row. So suppose while executing, it comes to this row, it checks what was the value in the previous row and then assign that value to this previous close column. Now, because we only wanted the values from the previous row, we just use the default parameters, which was only the column name. But what if you want the value from 2 days prior? So let's say you're on 11th April here and you wanted the value from, let's say, 7th April. Okay. So what will you do then? In that case, you need to add one more parameter here, and with the lag function you just insert one more comma inside the bracket and enter 2, because you want the value from the row which is 2 rows prior to the current one. Now if I run this, it will fetch the results which were appearing 2 rows prior to the current one. So I have 165 here and 2 rows prior was 172. That's why it's showing as 172. And obviously the first and second row will become null because it would not be able to find any value prior to this row. If you want to backtrack more rows, all you have to do is just increase the number here and it will fetch the records accordingly. So lately we've been working quite a bit with functions within SQL, right? So I thought we'd just cover 2 important date and time functions that we most probably use during our data cleaning or data analysis process. Now, before I get into the actual function, I want to show you the requirement in an Excel file first, and then we'll come back to this BigQuery environment. So the dataset that we're using is the same Apple stock dataset. So let me just quickly jump into an Excel file first. So the requirement here is I have a column which is a date column here, and I have a column which is a close column. So what I want to do here is I want to find out the average close price for a given month. But to do that, I would have to somehow convert these individual dates into a month. Now to do that, I would have to create a new column which will have only the month value in it. Only criteria here being I cannot convert a date column into a string, which means I cannot write this date column as April 22. Now there may be many ways to do this, but an easier approach would be I can create a new column here by the name of month val or any name that you like. And then in this column, I can assign the date as first day of each month. Like for example, in the first row, we have April, 11th of April. I can assign this as 1st of April. And wherever I have April, all those rows will have 1st of April value in it. Similarly, I have a row for May and this date says 2nd of May. I can convert this to 1st of May and again copy paste this 1st of May to all the rows where we have any date of May. So all the rows become 1st of May. What I can do is in Excel, I can create a pivot, drag this new column into the row value, and then in the values section, I can drag close and calculate average. As simple as that. Now, how will you do this in SQL? That is exactly what we're going to do today. And we're going to see 2 main functions to do that. First one is called extract and second one is called date. Okay, so let's just quickly jump into BigQuery environment and see how it's done. Alright, I'm in BigQuery environment now. I have a new editor window opened up. All you have to do is write a select statement. And here I would like to extract two columns from the data. First one is a month column, which we would have to create using our query. And the second one would be our close column, which we will be using to calculate the average price. So this is how it's done. Within select, I'm going to write a function which is called date. Now date accepts three parameters. First one is the year, second one is the month, and third one is the day. So what it does is it combines all those inputs together and create a date for us, right? So let's say if I write 2013 in the first parameter, which is year parameter, and I write 5 in the month parameter and 2 in the day parameter, it would mean 2nd May 2013. It will convert that input into a date. So we're going to use this date function here. So this select statement will convert this input which I gave, which is 2013 for year, 5 for month, and 2 for day, into an absolute date. Okay, so I'm gonna run this, and if you see in the result, it has now converted this into a date. The reason why you would want to convert a value into a date is because at times it happens that when you are running an analysis on a data, having a date column in a data comes in like a blessing, because it helps you analyze any trends or patterns in a data in a better manner. So now what we're gonna do is we're gonna remove this inputs from here, and instead I'm gonna write another function within this date function, which is called extract. And this is the second function that we're going to learn today. And what this does is it extracts any component that you want from your date column. Okay, so you can extract year, month, or day, or hours, minutes, anything from your date and time column. And the list of values that you can extract will be there in the link in the description. You can check it out if you want. But for now, we only require two things. First one is year and second one is month. So all you have to do in the extract function is write year, the component or the part that you want to extract, from the column name that you want to extract it from. As simple as that. We are writing a date function, and within the date function we are writing extract. This entire piece comes in as an year input. Then we got to write another input for the month. So I'm going to just copy paste this, and here I can just write month from date. And the last component is day, which is anyways I want to convert it to first day of the month, so I can just say 1, and that's it. And I'm going to close my select statement and say from Apple stock, and then I'm going to assign a alias to this. I can call it month val. And finally, the last column that we would require is the average of the close column. So I'm going to write avg close, and at the end, because we are aggregating or we are applying an aggregation function using average, we would have to group this entire thing. So I'm going to write group by month val, and let's run this. Now if you see, the results are perfectly fine. I have successfully grouped my value on the basis of each month and then assigned average values to it as well. Now if you want, I can order this entire thing by month val so that I can see everything in an ascending order. I'm going to run this. Now if you see, it has ordered everything together and you can see the results as well. Couple of functions which are very important if you would like to manipulate text within your tables. We'll be focusing on two main functions. First one is when you want to club couple of strings together, and the function that we are going to use for that is called concat. And second one is when you have to separate a long string on the basis of a certain delimiter, and the function that we're going to use is called split. To help you understand in a better manner, I'm going to first show you a simple example and then apply that same function on a table to manipulate string in a certain column. Okay, so without wasting any time, let's just quickly jump into it. The first function that we're going to cover is called concat. And let's say I'm writing a select statement here and I have two strings here. First one is big and second one is query. And I want both of them to be clubbed together. To club two strings or two or more strings together, the function that we're going to use is called concat. And then within that, I'm going to supply these values in it. And if I run this, the final output should club both of them together. As you see, now the final output says BigQuery. Let's go to a table. I'm going to use open powerlifting. Let's say I want to create a new column within this table, which will have name and the sex column club together, and I don't want to club it just like that. I would like to club it with an hyphen in between. So first the name and then a hyphen and then the sex. Okay. So to do that, I'm going to come back to this and I'm going to remove this and say select star from open powerlifting. But apart from star, I also need to create that new column. So I'm going to say concat, and within values, I'm going to say name, and I need a hyphen. So I'm going to enter a hyphen here within single quotes or double quotes, whatever you would like. And then my second column, which is the sex column. Okay. And if I run this, it has given me all the columns which are there in the table originally, but then at the end it has created a new column with my name field and my sex field with a hyphen sign in between, so that I can distinguish what is the name part and what is the gender part. So this is how you concatenate two or more strings together to generate a new output in a new column. Now what if you would like to distribute your column, okay, on the basis of certain delimiter? So I'm going to use this same table here, and within this table I have a column called equipment here, which has a value of single ply. Okay, I would like to distribute this string into two columns. First column should have single in it and second one should have ply in it. So how will I do that? I'm going to say select. I'm going to use a function called split, and within this I'm going to enter the column name which I want to split. So let's say equipment, and I would like to give it a delimiter by which I would like to split the values. Here the delimiter is an hyphen sign, and I'm going to say from open powerlifting. And if I run this, it will give me the results, and because there are so many results, I would have to filter this data out. I'm going to say where equipment like single. I'm going to run this. Now if you see, wherever we had single ply, it has splitted the value into an array. Okay, but this is not what we wanted. We wanted it to split into multiple columns. First column should have single value in it, and the second column should have ply value in it. Okay, so in order to convert your array which was created by the split function into a column, you need to use a function called offset. So after this, I'm going to say a square bracket and write offset. Now the offset function identifies a particular value or an item from a relative position that we have supplied within an array. So since an array starts with value 0, I'm going to say offset 0 because I want the value which is at position 0 in my array. Okay, and the 0 position in my array is nothing but single. Okay, so I want to identify the value which is there in offset 0, and I can give it a name as well. Let's say as first value. Okay, and I will give it a comma here and copy this entire piece. In the second line, I'm going to say offset 1 because the value in the first position of this array is ply, and I want that in a different column. So I'm going to say second val. Okay, and that's it. And I'm going to run this. So if you see, it has converted my array into two columns now, first val and second val. But there is an important piece that we need to understand here. We gave it a filter saying that I only want the value which has single in it. Okay, but what if I apply the same onto the entire table? This will give me an error. Okay, let's see. It's saying array index 1 is out of bounds. That is because for single ply, it did identify array in position 0 and 1. But for other items where we did not have any hyphen value in it, the split function only gave one value in it. So it runs this line perfectly because array 0, it found some value in those fields. But in offset 1, it did not find any value because there was no value to be found to begin with. Okay. So if I give you an example, it finds something for single ply. But let's say for this value, raw, it did find something on the 0 array position, but there was nothing to be found in the first array position. Okay. So that's why it's giving that error. To resolve this as error, we're going to use a different offset function, which is known as safe offset. Okay. Now what this does is it counters that error and inputs null wherever it did not find a value in that particular array position. Okay. So I'm going to run this again. Now it will run perfectly fine. As you see, I have values like straps, raw, and others to follow, which is there in the first value column. But for the second value, I have null values. Okay. Now, since there are so many row items, I don't want all the row items. I want a distinct value for each equipment that I have. So I'm going to say select distinct, and that's it. And I'm going to run this. This will give me the unique equipments that I have in that column and split it into first val and second val. So if you see, single ply has been split perfectly. Raw and wraps and straps do not need to be splitted because they only had one value. So that's why they have value in first val but nothing in second val. But for single and multiply, we have values in second val as well. We're going to cover two important topics. First one covers a scenario when you want to automatically schedule a query to run at a specific interval of time. For example, if you want a specific query to run every day for the next certain amount of period, then you can do that using schedule queries in BigQuery. And the second topic that we're going to learn today is called stored procedures, which will help you create a routine of multiple queries clubbed together which can be run on a single go, so that you can make certain changes to your data or table or get a desired output using stored procedures. So without any further ado, let's just quickly jump into it. To kick off things, we're going to start with scheduling a query. So here is a scenario. So let's say you have a table which is called open powerlifting here. Okay. Now this data set contains a list of athletes and their certain attributes. And this particular table gets updated on a daily basis. Now you have a secondary table by the name of OPW female, which is a subset of that table which you want to update whenever that open powerlifting table gets updated. Okay. And you know for a fact that every day at noon, open powerlifting gets updated. So you need to devise a plan so that after open powerlifting table is updated, your OPW female table should also get updated with the latest data. So how do we do that? So to do that, let's open up an editor window here. And in this, let's write our query. Now this query can be any query that you want. So I'm going to write a simple select statement here. Select star from open powerlifting, where sex is equal to F and age is greater than 20 and equipment is equal to raw. Now I want this query to run every day so that whatever changes I have in open powerlifting gets updated here as well. So to do that, I'm going to click on this schedule button here and click on create new schedule query. Give it a name. You can give any name that you like. The frequency of repetition for me in this case would be days, but you have other options as well like minutes, hours, weeks, months, etc. Okay. I wanted to run at 4:50 p.m. every day. Okay. So that's my start time, and you can also schedule it to end at a certain period of time, but I do not want that. You can keep this as default. So now if you see the prompt, it says scheduled to run every day at 1650 UTC starting now. Okay. Now after this, the next section is destination for query result. Now I want the output of this query to be inputted into my OPW female table. So to do that, I'm going to click on this checkbox here, and the data set where the OPW female table exists is called powerlifting. I'm going to select this. The table ID is OPW underscore female. And in the next section, it's asking whether you wanted to append the query or you want to overwrite. I would like to overwrite the output into the table and keep the selection as automatic. Let Google select the location. Okay. And I'm going to keep everything as default. You can also choose to have a email notification once your query has run, but I'm not going to do that right now. And then I'm going to save this. Right now in my system, the time is 4:49 p.m. So in just few seconds, it should run my query and give the output into this OPW female table. Now, if you want to check whether your scheduled query has been executed successfully or not, there is a section here in BigQuery console environment which says scheduled queries. Okay, just click on this scheduled queries. You'll be able to see the list of queries that you have scheduled. And as you see, the female athlete's query has been scheduled to run on April 24th, 4:50 p.m. Okay, and if you click on this display name, you will see the transfer run is in progress right now. And if you click it once more, you will see that it's currently been executed. Now, if you see, the status says completed successfully. So the data set within the OPW female table has been updated successfully. So I'm going to go back to my SQL workspace by clicking on this icon here. And if I go to the table, which is OPW female, I can see that the data has been updated. If you remember, the condition was sex female and equipment raw and age greater than 20. So that is exactly that we have here now in the output. So since we have scheduled it, now it will run every day at 4:50 p.m. and update the dataset within this table using the Open Powerlifting master table. So now I hope you understood how you can schedule a query to run at a certain period of time. Now moving on to the second topic of the day, which is stored procedures. And the reason we use stored procedure is to create a routine or create a set of instructions for SQL to run, which might have multiple smaller chunks of queries embedded within them to conduct certain operations. So to create a stored procedure, let's open up another editor window here. And the keyword for creating a new stored procedure is create procedure. And after that, write the name of the procedure. So you can write any name that you like, and then close the statement with a opening and closing bracket. Come to the next line. Make sure to give it an indent so that there is no confusion while writing the code. And the next statement is begin. Okay. And the procedure ends with the statement of end. Now, whatever statements that you write in between will be considered as a single routine, and when you try to run a procedure, all those queries will run one after the other. So let's imagine a scenario where you wanted to achieve the same result that you achieved with the schedule query that you did to OPW female, wherein you want to override the existing data in OPW female with whatever data you have in Open Powerlifting at the current moment. So to do that, I'm going to first write a delete statement, because I would like to first remove whatever data that I have in OPW female. So I'm going to write delete from OPW female where sex is not null. And then I'm going to end this statement with a semicolon, because since stored procedures can have multiple queries in them, there should be a way to segregate those queries from one another, right? So semicolon is the way to do that. So now SQL knows that this delete statement ends at this semicolon. With this, I have deleted whatever data that I had in OPW female. Now I'm going to write a second statement, which would be an insert statement. Okay. And I'm going to say insert into OPW female. And the data that I want to insert will be coming from a select statement. So I'm going to say select star from Open Powerlifting, where sex is equal to F and equipment is equal to single ply, and the age would be less than 20. Okay, so earlier we had greater than 20, now it would be less than 20 age. And I'm going to add a semicolon here as well, so that I know that the insert statement ends here. So with this, you learned a new way to insert the data as well, because if you remember my previous video about insert statement, we learned how to insert a value using the values clause. Now this is how you insert a value inside another table using the select statement. So I'm going to run this. But before running, I want to take your attention to one small error that it is giving. It says routine update at least must be qualified with a dataset. So what it's saying is, before this name that you have entered, you need to enter the dataset name. My dataset here is called powerlifting. So I'm going to write powerlifting dot update athletes. Okay. Now the error has gone and I'm going to run this. Now if you see, BigQuery has automatically created a routine here and it has been segregated separately from the other tables, and this says routines, and within this I have an update athletes here. And if you want to see what query is written within that, you can see it by clicking on this and you'll see here routine query. Okay. Now obviously you can edit this query by clicking on this edit stored procedure button. Now for now, we need to run this so that this OPW female table can be updated and the new conditions can take effect. Okay. So what I'm going to do is I'm going to open up another editor here, and within this I'm going to say call. Okay. Now call is a keyword used to run a existing stored procedure. Okay. I'm going to say powerlifting dot update athletes, because update athletes stored procedure exists within the powerlifting dataset, and then end the statement with a opening bracket and a closing bracket, and I'm going to run this. So my stored procedure is getting executed, and at the bottom you can see whether it has executed successfully or not. Now I'm going to click on this OPW female and check if everything is working fine or not. Now in the preview section, it says there is no data to display. Now this might be because the condition that we gave in the update athlete stored procedure might not have fetched any results. So let's just edit this first. Okay. So now I clicked on edit stored procedure, and instead of single ply, I'm going to write raw, and then I'll click on this run. But before I click run, if you notice, earlier when we created that procedure, we wrote create procedure, right? And then the procedure name. But now when we are editing, it says create or replace. Now what replace does is it checks whether a procedure with the same name already exists or not. If it does, then it updates that existing procedure. So you can use this replace statement while you're creating a procedure in case you want to simultaneously check if a procedure exists or not, and if it does, then update that procedure instead of creating a new one. So now I'm going to just run this, and the procedure has been updated. So let's go back to the editor window again and click on this run button where I've written call powerlifting update athletes. Okay, so this will run the stored procedure and the queries within them. Now let's check if we have any results or not. So I'm going to just go to the preview section. Now if you see, I have some data here, and the condition that we have written, that's exactly what we have got in the output. We have covered quite a lot in SQL, and I think now you might have a good understanding of how to work with SQL and especially how to work with BigQuery. Now, one last topic that I would like to cover in BigQuery and in SQL is called views. So up until now, you've seen what is a dataset and how we can create a table within a dataset. And we've also seen in one of the videos, once you've written a query, how to save a query so that you can use it for future reference. And just in case you don't recall what I'm talking about, let's say if I write select star from Apple stock, okay, and I'm using the same dataset that we used earlier. Links will be in the description in case you want to download the data. I've written this query, and for future reference, if I want to save it, I can do that by clicking on this save button here and clicking on this save query. Okay, it will ask you whether you want it for personal use or you want it to be public, or whatever permission you would like to give it, and then obviously ask you for a name. So let's say temp apple. Okay, and then I'm gonna save this. What it does is it saves that query in your environment so that tomorrow when you want to refer to that query once more, click on it, it will show you the query that you have written. But now today we're going to cover a topic known as views. Now views are very important because views are nothing but a virtual table that you create within SQL. Okay, now what do I mean by virtual table? Whenever you look at these tables that I have here, Apple stock or sales or whatever it is, right? These tables are physically stored on my cloud platform, okay, which means it's taking up some kind of space and some kind of bandwidth within my cloud platform. Or if you're using a more traditional database systems like SQL Server, it will occupy some kind of space in your local systems. Now, when you talk about views, it's a virtual table. It's just a shell which has a query inbuilt into it, and whenever you want to call it or whenever you want to refer it, you can do that and the query will be processed at that very moment. Let me show you an example how you can create a view. There are two types of views. First one is a standard view, which is acceptable and applicable in almost all database systems. And second one is materialized view. We'll get to materialized view in a while, but let's just first understand how standard view works. Okay, so there are two ways to create standard view. First one, I can straight away write a query. Now I have written this query. I would like to save this query as a view. So I'm going to click on this save button here and click on save view. It's going to ask me in which project I would like to save that view and the dataset that I would like to save it in, and also the table name. So it's asking for a table name, but remember this is a virtual table. Okay, it will not occupy any space in your system or cloud. So I'm going to write, let's say, temp apple, and I'm going to say save. And if you see right inside my list where I have all the tables stored, I'm seeing a new table by the name of temp apple. And if you see, the icon for that is different from the icon for Apple stock and sales. Apple stock and sales are a physical table that exists in my cloud, which is occupying some kind of space, but this is a view which is not occupying any space. Now if I close this out and let's say I write a select statement, select date and close from, I can refer to this view that I created. If you see, it has fetched me the records from that view, and I can use that view in any kind of query that I want. But be very cautious while using views to perform your data analysis activities, because this is a virtual table. And if you compare the performance between a physical table and a virtual table will always have a better performance while running your queries. So if views have bad performance than a physical table, then why do we actually require a view? There might be couple of reasons, but main reasons that I can highlight is, first of all, let's say you have a table with a huge amount of data set. Out of that entire data set, you only want a specific portion of the data to do your analysis or to create a report of some kind, which will be eventually used by a user. So views will help you to restrict user from having access to the entire table. Instead, user will only have access to the views, where you might have applied a where clause to limit down the data which user can interact with. And the second reason that I can think of is, let's say you have table A, B, C and D, and you have to create an output by joining all those tables together and have a couple of filters applied to it as well. So every time you do an analysis or every time a user interacts with your final output, you or the user should not be worried about applying all those joins or applying all those where clauses again and again to interact with your final output. An easier way would be to first of all apply all the joins and all the processing that you want to do in your final query, create it as a view, so that every time you want to interact with the final output, you can directly interact with the view itself and write a simple select statement on the view. Now you might be thinking, why do you want to create a view? You can just save the query, right? Like we saw earlier in this video. But the only problem is you cannot run a select statement referring to a query. You can only run a select statement on a table or on a view. So that's why we might require views. There are other reasons as well in terms of data integrity and access management, but that is something which is out of scope from a data analyst perspective. But it's a good to know information, and if you want to read more about views and what are the advantages that we have while creating a view, I'll leave a link in the description. Feel free to check it out. Now coming back to our main topic, you can create a standard view using SQL statements as well. To do that, what you need to do is, before your select statement, write create view. That's the keyword to creating a view. And after you write create view, you need to write the name of the view that you want to create. Let's say I want to create new temp apple. Okay. And you write as. But before creating a view, you need to also mention which project and which dataset you want to create that view inside. Okay. So I want to create this view inside this customer data. So I'm going to write customer data dot new temp apple, because I want to create a new temp apple view inside the customer data. Okay. And now if I run this, it will create a standard view for me. As you see, the view has been created here. Now, in case while you're working, you have more than one project, you would have to write the project name as well before your dataset name. So from this example, I would have to write Lithe Sonar 327208 dot customer data dot new temp apple. So keep that in mind while creating the view using the code. Now, this is how you created a standard view. Now comes the second type of view, which is known as materialized view. Now, what is the difference between a standard view and a materialized view? In a standard view, the data is not refreshed until you call the query. But in a materialized view, the moment a backend table which that view is referring to is refreshed, the data within that materialized view is also refreshed. So which means now the benefit of that extra computation which happens in the materialized view is, performance wise, it's much better than standard view. Now, how do we create a materialized view? You need to write an extra statement or extra keyword, which is create materialized view. And let me just change the name slightly here, new apple 1. And when I run this, so now it has given me one more error here, and it's saying materialized view can only reference native tables. Now, because I've used a view here, I would have to change that to a native physical table. Now, as you see, a new view has been created. This is a materialized view, and that's why the icon that you see in this is different than a standard view.